I'm a math teacher. I'm a math teacher. 'Cause I know sometimes students like to hate. So why don't you listen, 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 listen. And I'll teach you math. Dear students, I was wondering if you really listen to me. Dear students, are you listening clearly? Dear students, don't waste your life. Dear students, I just want what is best for you. Dear students, why don't you listen? Dear students, you can do it. Dear students, Hey, well, this is Mr. S, and now what we're going to be doing is a video book on linear equations. So sit back, relax, and be taught on linear equations. So here we go. Alright, so what does linear actually represent? It represents a straight line. So what's important about that is it cannot be curved. Alright, so here we go, not curved. It has to be straight. So what are some characteristics of being straight? Is that it's constant. It doesn't change. It doesn't go sideways. It doesn't curve. Right? It stays the same. Alright, so this is what you really have to know about linear. Alright, and what does equation mean? Alright, so two expressions that are equal. So here we have expression 1, 2x plus 8, and we have expression 2 as y. And so it's whenever they are equal. So when x equals 1, y has to equal 10. When x equals 3, let's say 3 times 2 is 6, 6 plus 8 is 14, y has to equal 14. Alright, they have to be equal. So what are some examples of linear equations in real life? So pumping gas is an example. It's again a constant rate of change, and again you see the dials of the gas thing going at a constant rate of change. It's linear. As well as melting snow. Alright, when the sun melts it melts at a constant rate. Even though it may seem it goes at a constant rate of melting into water. When you drain your water from a pool or a bathtub, again, it drains at a constant rate. You can even hear that sound. It's going to be a constant rate. Now, what we're going to be using for this example is cell phone companies. If you go overage on your gigabytes or your memory usage, it'd also be a constant rate on depending on how much over you go, how much your bill will be. Again, it's a constant rate. So that's what we're using. So here we go. This is going to be T-Mobile. Alright, so what they charge is $40 a month and then $2 for every gigabyte you go over your plan. So don't do this. Alright, so hopefully what will be happening is you're not going to go over at all and your total cost will be 40 bucks. If you go 1 gigabyte over, it'll be 42. 2 gigabytes over, it'll be $44. So again, you see we're repeating the same words over again. We're going to put the over here, and you can see the blue kind of goes with the blue, the green goes with the green. Alright, and so you can see it's those same things. The blue is the gigabytes over, the green is the total cost. So you really want to organize this data to make it a little bit more efficient. And so you can see instead of having to repeat those words over and over again, we put this into a table and we can get rid of those words that, again, so we save some time. And so this is a table, and then what we want to do is go from that table to a graph. Alright, so we're just trying to learn about the basics of a linear equation. So we first get in that table. So you see we're going to put on the graph. We start at that 0, 40 mark. So we start off at 0 on the blue axis, and then we go up to 40 on the green axis, and there's our dot. Okay, and then we go on to the next one with the orange one. So we start off at 1 for the blue axis, and then now we go up to 42. So it's going to be a little bit taller than that 41, and we'll stop right there at 42. And then the next one, for gigabytes over of 2, the white dot starts at 2 now, and then it goes all the way up to 44. Alright, so there it goes again a little bit above that 42. And so now you can see that what do these points do? Alright, and again we keep going with the other couple other points. We can see these these points form a what? Alright, it forms a line. Alright, and this is why we call these functions linear. Right, we call these functions linear because the points form a line. Alright, so you can see that line I highlighted in blue, right? Linear equation, right? It's all because of the graph, not the table, not the situation, but because that graph, that visual representation, shows a line. That's why we call it a linear equation. We get this constant rate of change, and that constant rate of change is really seen in the graph of the function. Alright, so let's keep on going on this by deleting the red box, and we're going to just look at the table and the graph, because what we want to do is create an equation. Alright, so we're going to look at this patterns in the table first. Okay, so Again, we see this pattern in our table, and again, I think it's obvious to see, but let's just point it off. All right, you're starting at 40, we add 2 once. All right, but then we go back to 40, and we're going to start off at 40, and then we're going to add 2 twice. All right, but we're starting at 40. All right, we're adding 2 twice. Now we're starting at 40 again, and now we're adding 2 3 times. And then the last one, again, we're going to start off at 40, then we're going to add 2 a total of 4 times. So you can see we're adding more and more 2's because we're going more and more gigabytes over the plan. All right, so first we look at that pattern. The second thing is let's assign a variable to each one of these. So the x represents going over, and the y represents the cost in dollars. Okay, to help us create this equation. And then we want to see a pattern between the x and the y. So what's that blue value tell us with our y value? And you can see that what it actually is, the blue values, the x values are telling us how many times we're adding 2. Okay, and so what does groups of addition? Hopefully you're going to say multiplication. So how are we going to create this equation? All right, first is we're going to take that 40, so you can see up in that top of the screen, I move that 40. We're going to start off at 40, right? Because every time, right, we started off at 40. Now, what told us how many 2's to add was our what? All right, our x value. All right, so you can see we brought that x value in here, and we're going to use multiplication to set that up. So our equation is 40 plus 2 times x. All right, so that x tells us how many 2's we're adding. Okay, so that's how we get this equation for this problem. Again, that groups of 2, we start at that 40, and then we use that multiplication because it's that groups of 2. Okay, so all from these patterns. But so we have the big 3, like what I like to call it, in this algebra. So we start off with the table. That's what we started off with. So we really need to be solid on that, creating a table. Okay, we really need to be solid on a graph. All right, so being able to graph these points, and again, if you want to rewind the video to watch how we graphed and did the table again, that's what the perfect thing is rewind it. And then also knowing the equation. The equation is the one that's most difficult to understand. All right, so again, that value, we started off at 40, and then we're adding groups of 2, so that's why we used multiplication to set that up. Okay, and again, that's a difficult concept to add, to understand, not add, but understand that multiplication. So what we're going to do now is on the video, the screen, we have a new question that I want you to answer. So let's pause the video right now. Again, pause the video and read the question. All right, so the new video is going to change in 5, 4, 3, 2, 1. Here's the new section. All right, so now we have to make it harder, right? So we want more of a challenge. So we're going to challenge ourselves a little bit. So now we're at Verizon, not T-Mobile, and what they tell us is that if you go 0 gigabytes over, the cost is $35, and if you go 4 gigabytes over, the cost is $55. So we're not going to go over how we put it in a table again, but we did that last problem, so now we have this, and now we want to kind of compare, see, okay, well, what is the difference? How do we make this a little bit harder? So that's what I want you to think about now, is that what is the difference between these two plans? All right, how did we make this problem harder? All right, and that's the thing. We don't know the cost of 1 gigabyte for Verizon. All right, and so we knew the what gigabyte cost, but now we don't. So how do we find this cost of 1 gigabyte? All right, because we know 0 and we knew 4, but we didn't know the cost of 1. All right, so to do that, we want to look at, well, how much did the cost change? The cost changed 20. All right, and then we also know that the gigabytes changed 4. All right, what we don't know is how much did it change by 1 gigabyte. All right, so we do know that each 1 gigabyte costs the same. That's why we can take that $20 of the cost difference divided by that 4, because we know it's going to be equal since we know it's linear. So this is we only can divide this by the fact that we know it's linear. All right, if it's not linear, this will not work. And so 20 divided by 4 is 5. And so we know 1 gigabyte cost $5. This is called the rate of change when we're talking about it in terms of the table. All right, we want to know how much it's changing every time. So we can use that now, and we can see that, it's, yes, sure enough, we're adding 5 every time is our rate of change. So every gigabyte over we go is going to cost us $5. And so we found that by finding the cost of 1 gigabyte. Now, how can we do this on a graph? So I'm going to, again, go through the graph a little bit quicker this time, because we already, again, reviewed go back to the video to review how to graph if you forget. And so we have our graph. And so what did we start off with last time? It was 20. And so you see that 20 is a visual representation over 4. But we want to know how much we did it for 1. And so we can see that's 5 to 1 by, again, dividing that 20, rise, divided by the run. 20 divided by 4 is 5. But since it's in a graph, this is called the slope. All right, since it's a graph, it's called the slope. All right, so again, we took that 20 divided by the 4, and we get the 5 to 1. All right, so what is the equation? So now we found that rate of change. All right, how are we going to create this equation? All right, so again, we start off at that 35. All right, we know where we started off, and now what are we adding? We're adding groups of 5. All right, and so we're going to multiply that x by 5. So we have, when it's 1 gigabyte, we have 1 5. When it's 2 gigabytes, we have 2 5s. All right, and so on and so forth. And so our equation is that y equals 35 plus 5 times x. But again, you see that table? It's plus 5. That is the rate of change. That's what we didn't know. And the slope, they call it 5. Right? The rise over the run. You're going up 5 to over 1. We always want per 1 because that's what this whole problem was about. Was why it was more difficult, is because we didn't know how much it was per 1. And that's what you have to know for linear equations. You have to know, right, the rise over the run, right, or the rate of change, how much it's changing for every 1, not for several ones, but for 1. So you know that rate of change and what to multiply by. So let's pause the video, and this is a new problem to help you find that rate of change again. So again, you can recap this video. Let's pause it, please. And again, this will help you figure it out on your own. So we're going to be switching videos soon. Alright, so here we're going to make it even more harder now by AT&T. Woohoo! Alright, so now the problem is we have 3 gigabytes over at $45, and we know 8 gigabytes over, which is $60. Alright, so that's how we're going to make this problem a little bit harder. So we're going to put this information in our table, and you can see this is similar from our last problem. So you can see we're building up, getting more and more difficult. But we already know this, right? Because we practiced it last time. Alright, we know the cost increase is $15. We need to know how much it is for 1 gigabyte. But how much is this $15 increasing? It's increasing for 5 gigabytes. But again, we know each 1 gigabyte costs the same because it is linear. So then we can take that 15 divided by that 5 to find out how much it's costing for 1 gigabyte. Alright, and again, this is the table, so it's called the rate of change. And so we're using that rate of change, that plus 3, and you can see, sure enough, it does work in that table. Alright, so again, this is from that previous problem. Alright, so we're reviewing it a little bit. So again, we're going to graph it quick. Again, just to review this on the graph again as well, just so you can see more and more examples. So you see that 15 to 3, that rise over the run. Again, this is in a visual form, not in the table. Alright, so we take that rise over the run, 15 divided by 5, we get that 3. So our equation is y equals 3x. Okay, so we have that y equals 3x because that's our rate of change. But what are we missing to finish this equation? Okay, so we're missing something. All right, what is that something? So to help us, let's go back to that original problem that we've already done and look at, well, what did this problem have that we are missing now? So you can see that 2x, right, that rate of change. We had that rate of change, but now we also have that 40. What does that 40 represent? Okay, and that's what we're missing in our problem right now. And again, this is how we're going to make it a little bit more difficult. So what are we missing? So again, thinking about that a little bit more. All right. So is that plus 40 in that one? And sure enough, what is it? It's that start value, that initial value. So we didn't know the rate of change last one. This time we don't know what the start value is. All right, where does this begin at? Where does this start at? So several ways to find out. We'll go over one thing. So where is the start value? It's always a 0. Remember, 0 is a special value. All right, so we start at that 3 gigabytes. And we're going to go backwards till we get to 0. Since we know that rate of change, so we're going to go backwards 3. All right, and so you can see it's $36. So we can do that in a table, and we can also do it in the graph, right? So we go down 3 over 1, down 3 over 1. And again, I know that down 3 is hard to see because it's, the graph is not that visual, but you can see it's still on that same point. And so we can see the start value on both the table and the graph. All right, so our start value is 36, our initial value, otherwise called, and our y-intercept. All right, is also, if you can see that graph a little bit better, is the same. Both are 36. And so what's our equation going to be right? It's going to be that y equals 33x plus 36. 36 our start value. And again, are there other ways to find it? Absolutely, but this is just a couple ways. And again, just thinking outside the box. So again, the first problem we had was we had to have difficulty finding the rate of change, and now we had difficulty finding this start value. So let's pause it and let's see if you can do another problem. Again, it's getting more and more difficult. So let's pause the video and see if you can figure this out. And again, if you have trouble, just rewind the video and watch it again for more practice. All right, so answer the question. Pause the video. It's going to move in 3, 2, 1. Here we go to the next one. Alright, so let's review on what we've talked about today. So to review, let's go back to the horizon problem. We were first introduced to the difficulty of finding that rate of change. Okay, so we knew 55 and 35, but we didn't know how much it was changing for every one. So what we did was we found out how much the cost was changing. It was change 20 for 4, and you can also see that on the graph, right? So change 20, change 4, rise over run, right? We find it for 1. Alright, so we divide it because we know it's linear, it's going to change the same for every one. So the one on the graph is called the slope, the 20 divided by 4, and we get that 5. And that 5 in the table is called that rate of change. Again, the same thing, just called different things because it's in a table and it's in a graph. And so we can see plus 5 in the table, right? You're adding 5, and you can see as that pattern increases. Right, it's always that same, we're multiplying by that 5, just in a different way of seeing it. Okay, so that's the first thing is you need to understand that slope. Okay, the second thing is that y-intercept, the start value. So you can see a start, again, it's always when that x is 0, all right? And when that x is 0 in the graph is where that y-intercept. So, but again, both are the same value starting at 35. And again, the y-intercept can be, the start value can be different, but it's the same thing. So you have to find the rate of change, or the slope, and then also the start value, or the y-intercept. So again, just looking at these, we're starting at 35, and then we're multiplying it by 5 because that's our rate of change on that graph. And that's it. That's what linear equations are all about. Thank you for watching. And again, I know this can seem pretty overwhelmingly of how going so fast over these, but that's really the beauty of this video is I don't expect you to learn everything just watching this once, right? I expect you to go back to the video. Maybe you need to watch the first portion over and over again, then the second portion over and over again. Or maybe you get it and all you need to do is watch the third section a couple times. So again, it's how hard do you want to work. Alright, so I really encourage you to work hard. Watch this video a lot. Again, you're not going to get it the first time through. I know it's just a lot thrown at you at the beginning, but that's what you need to do is sometimes maybe you just need to watch it more than one time, alright, and really go back and think about these things. So that's how you learn, is by thinking things through. Alright, so again, thank you for watching, and I hope you learned something, and again, I hope you use this video to help you even more. Thanks. I'm a math teacher. I'm a math teacher. 'Cause I know sometimes students like to hate. So why don't you listen, 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 listen. I'll teach you math. Math. It's evident there is hate, but let me teach you. You take the lead as a sentence and roll, and I'll teach you math. I know I make mistakes, mumble my words. I'm sticking to the script, teaching all the math. I don't need any recognition, don't need any love. Why gain attention when there are people without math? And my lives are perfect, so don't touch the best. I can't endure this lazy attitude from students. So word to every hazy, hater, lazy student. We're all gonna use math, and I know it. Yeah, so if you need me, I'll be available after school. Praying the whole school start taking education serious. So let me fall back, start giving my suggestions. When I get obsessed, I end up tripping and messing up. But I'm who I am, I are a teacher leading math knowledge. Yeah, I'm a math teacher. I'm a math teacher. 'Cause I know sometimes students like to hate. So why don't you listen, listen, listen.